Hello everyone. In the previous video we have discussed electrical, mechanical, chemical and optical properties of nanomaterials. In this video we will discuss remaining properties, that is thermodynamic and magnetic properties of nanomaterial. So as the size of these nanoparticles decreases, then more percentage of atoms are present on the surface. So as more percentage of atoms present on the surface, more percentage of atoms exposed to the surrounding temperature, and thus the melting point and boiling point of these nanoparticles decreases. Okay, you can see this animation. In this animation, melting of ice cube has shown, and if you observe it carefully, as the size decreases, melting rate also increases, right? So as the size decreases, what happens? More percentage of atoms are present on the surface, hence melting rate increases. Okay, and the same principle is applicable for this nanomaterial or nanoparticles. So as the size is smaller, melting point and boiling point of nanomaterials decreases. Example is again gold. Gold, which is solid at room temperature in bulk form, becomes liquid because its melting point becomes smaller than the room temperature, right? And as melting point and boiling point changes, the enthalpy and entropy also changes. Now due to increase in surface area, there is an increase in adsorption sites. So more number of hydrogen atoms are adsorbed on the nanomaterials, and thus these nanomaterials can be used for hydrogen storage. Okay, so as the size of particle decreases, there is increase in adsorption site. So hydrogen get adsorbed on the nanoparticles, and thus these nanoparticles can be used for hydrogen storage. The next is magnetic properties. Now we know that there are different type of magnetic materials, ferromagnetic, ferrimagnetic, antiferromagnetic material, diamagnetic material, paramagnetic material and super paramagnetic material. So these properties, they are dependent on the orientation of magnetic domains. Okay, magnetic domains are nothing but the region in the particle where all the dipoles, they are oriented in the same direction. So as when the size of particle is bigger, in this bigger size particle there are number of regions in which these magnetic domains, they are oriented in same magnetic dipoles, they are oriented in same direction. But as the size of particle decreases, the regions, they go on decreasing, and nanoparticles, they are very small in size, and therefore single nanoparticle can be considered as a single magnetic domain. Okay, and thus the nanoparticles, they are single domain structure where all the spins are aligned in one direction, and hence it possesses net magnetic moment. But this magnetization randomly flips. Okay, this direction of magnetization, it randomly flips, and thus the average magnetization becomes 0, and it is known as super paramagnetism. But when external magnetic field is applied, magnetic moment of whole crystallite tends to align in single direction, and thus it leads to the net magnetization. So this we can understand with the help of this video.
We saw earlier that information can be stored by magnetizing.
So this is one of the application that is magnetic memories. As you can see, there are magnetic domains oriented in different directions. So this is one domain. Now if we consider the nanoparticles, these nanoparticles, they act as a single domain, and these nanoparticles, they flip their direction. So now they are in single direction, but as they vibrate, they flip their direction. So as they flip their direction, the orientation of magnetization is continuously changing. Okay, you can see here. So it is continuously changing. Flip in direction takes place. So as there is a random flip in direction, there is no net magnetization, though these nanoparticles, they are single domain. So average magnetization is 0. But when magnetic field is applied, all these magnetic domains, they are oriented in one direction only. There will be no any flip in direction, and thus it gives us very high magnetization when magnetic field is applied. So this using this property, we can make hard magnets, very high field magnets by using this nanomaterials. Thank you.